Alright, hello everyone. In this video we are talking about functions, the next few videos are going to be several things that you will need to complete Project 1, which involves functions and using checker. Now functions, really along with every other topic we've talked about beforehand, will be continued to be used throughout the whole semester. So really every topic we run into is important since everything builds on each other, so don't forget that. In this video we're going to be talking about a few new keywords. We'll be talking about def, which is how we define functions. That's what DEF stands for, define. We will talk about return, the return keyword and how it's used. We'll talk about a vocab word. This isn't actually a Python keyword, I suppose, but it is a vocabulary word called parameters. And we're going to be going through all the what, when, why, where, how in this video. So how do functions work? Why do we use functions? Really understanding how parameters work, which is what I typically see most students misunderstand. So this one right here might be the most important topic today. And then we'll do some examples of functions. We're going to take some of the stuff we've been doing before and convert them into functions. So we'll look at examples of what does something look like without a function and what does it look like when you use a function. And then the last two topics are a bit more niche. They're not as broad as the other topics. We're going to talk about multiple return types and default parameter values in this video. There are topics we're not going to get into, such as basically a list of parameters. So we're not going to be talking about args or quargs or other specialized functions. We're just starting with the basics today. And depending on how long this video goes, I'll try and keep track. We might put this into multiple videos since this is a big topic. All right, so let's actually start with an example here in our code. Let's just make a function. Let's just go right into it. So let's make a really simple one. Let's make a function called multiply, where we're going to multiply two numbers together and return the result. So we have a and b here, and we'll return a times b. So that right there is a function. It's giving me a little yellow underline because it wants two lines of empty space between this comment and this header. Oh, it looks like I'm going to be forgetting about some vocab that we need to define as we go through the video. So I'll put them here. Maybe we'll move parameters as more of a vocab rather than a keyword. I'm sure I'll come across a few more vocabulary, but we'll define all of these things. And anyways, this is a working function. So when we run our function, we can see what happens. Nothing. So this is the first big thing about functions. Functions are more like instruction sheets for how we handle data. We're taking in two pieces of data here, and we're going to do something with those pieces of data. In this case, we're multiplying, and we'll talk about the return later. But we're not actually calling this function anywhere. We have it defined, but we're not using it yet. So for these keywords, we can define these briefly. So the DEF is how we start the definition of a function. You always have to start with it. Capitalization does matter. It has to be all lowercase. Yeah. After that, we have the function name. In this case, our function name is a multiply. So the way we name functions is the exact same as naming variables. Same rules as naming a variable. I'm going to say, however, what's the main difference? I would contend that functions should really have some kind of verb in them right? Functions are doing something to data, right? So there's probably some way you can describe what is being done. So it's really nice to fit a verb in there. Sometimes if you don't have a verb and it's just like some noun, for instance, maybe we're working with Pokemon and all it says is Pikachu. I don't know what we're doing with that Pikachu. Is it fighting? Is it being healed? Is it accessing some quality? I don't know. So the verb is really helpful to make sure that we don't lose the context of how that function is going to be used to work with the data. So function names, I'm going to say function names should have a verb in the name somewhere. But besides that, everything applies for the name of the function. So we should start with a letter. We should use a snake case, so separating everything by underscores. We should use letters. We really should avoid numbers. It shouldn't be too long. We don't need any filler words, and so on. Another thing here, since we've been talking about keywords, is we couldn't name our function the name of a keyword. So anything that is highlighted a different color is a Python keyword. So if I try to name this def, we're going to get an error. It's going to say identifier expected. It thinks that we are. I wonder what it does think here. I'm not sure exactly how it would be interpreting this, but yeah, I can't use this keyword. We can't call it if, right? If is and also a Java keyword. We couldn't call it elif. We couldn't call it import. We couldn't call it. What else have we seen? Some of the. Well, actually, we actually could call it something like print. I think yeah, it will allow this, but it'll give us a warning. So I would, in general, try to avoid naming functions the same thing. This in programming is something called overloading. This is called overloading a function name, which we don't really want to do yet. We might want to do it in the future, but not right now. Okay. And then what's this return word? What is going on here? So this is another important part of functions. The return is it is going to. I'm trying to think of the right way to describe this. Let's say we call our function. It'd be easier if we call our function and show how we do that. So if we want to use this function, we could do something like this, where we call the name of the function, multiply, and pass in two values. 5 times 6 is what we would be doing here. And we could run that code. Now, if we do this, we will do the math here, and we will return the value. But we'll see, we're not seeing anything. So what's happening? What's happening is that this clause here is going to return the value of this expression. So when we use return here, we're saying to return to the place that we called our function and substitute it with whatever the value of the expression is next to the return. So any expression can go here. It could be a single variable, it could be a single number, it could be multiple variables that are being evaluated. You can use PEMDAS. It could be a condition. Anything that's going to evaluate to a single value can be returned, which ends up being most things. So 30 would be returned here, but since we're not like printing that value, it just kind of disappears. It's garbage collected on the next line. The computer knows we're not using this value, and it store it. So, and if you don't store anything, well, it's gone. So what do we want to do? Well, we want to take what is returned here, which should be 30 in this case, and store it in some kind of result. So maybe I make a variable called results, and I set this equal to this function call. So let's make a little note here. This is a function call that returns 30 and stores it in the variable result. Okay, so now when we print result, we will actually see our value. We'll see 30 here. Okay. So when we define return here, what's actually happening? This is when we evaluate an expression. Could be a single variable and substitute the value with the function call. So what happens? We hit this line here. Well, actually, even before that, we're going through our script, right? So we start line 1, we skip our large multi-line comments, we reach this definition here, but this is just a definition, right? And with definitions, we skip over them. So we would skip right over and we go to line 30. Line 30 you would try to evaluate this right-hand side of our equation here using this assignment operator. And when we evaluate this, it's a function call. So that means we jump to line 26. So just like how we had if statements that skipped lines, right? This is also skipping lines, but now we can actually go backwards. Kind of. I mean, these functions are really operating in their own environments. So we're more like, I wouldn't say we're skipping backwards. I would more say we're skipping to a different environment, something called the stack, the function stack, where we evaluate functions in order, and it kind of operates like, no, I don't want to talk about a stack now, but maybe later we'll talk about what a stack is. That would take a little bit. So we jump to this function call, and we evaluate this function. Well, how is that done? Well, what we can see here is we actually used some values here. Do we remember what these are called when they're just the numbers? It's a very important vocabulary word that I will reference a lot. The word I'm looking for is literal values or hard data. Two different vocab words. So these are literal values or hard data because they're not in variables, right? They're just the straight up numbers. And we are passing these into the parameters here. Something else to note, and this is something that PyCharm does, is you see the little A colon and B colon? I did not write these values. I didn't write them. If I delete this value here, you'll see the A colon disappeared, and now you see it replaces it. The little grayed out values here are actually just it's just PyCharm telling us what parameter these literal values correspond with. All right, the problem with hard data like 5 and 6, or like if we're using strings, cat in quotes, or true or something, is they don't have any context. You know, they're values, but we don't know what they really belong to. Like, are these for the height of something or the width, or is it for defining the name of someone? So this kind of gives us context for the hard data we're using as we pass these values in. What happens next is these are the parameters. A and B are the parameters. So let's define what a parameter is. A parameter is really just a local variable that is used at the start of a function that holds the values passed in from the function call. So let's break down this little sentence here and talk about it a little more. What we've done is we have a function call here, and we're passing these in, right? We're kind of teleporting to this space here, We're delivering 5 and setting it to this local variable a. Why do I call it a local variable? Well, it's local because this variable a only belongs to the scope of this function. Okay, we're really testing all our vocabulary here, right? So if you're confused after watching this video, basically watch it again, because we just have to know our vocabulary, and that's probably what is confusing you if you don't know some of the previous vocabulary we've talked about in these videos, because we're using a lot here. But the scope of this function is everything indented, which is really just one line here, right? We didn't do anything except multiply these values and return them in this function. So these local variables that we define only exist here. If I try to use a and b outside here, let's say I try to print a, the variable a, it's going to say, hey, unresolved reference a. That's another way of saying that there's no variable called a in the scope of my script here, right? Because a is local to this function. It doesn't exist outside of this. So you have to remember that. So why do we do this? You know, what's the point? Why even use variables here? Why not just pass in 5 and 6? Or what's the deal? Well, the deal is that this function allows us to, it should allow us to reuse the code to get different answers based on our inputs. So I could make another variable. I'll call it diff result, which is short for different result. And we could do some different multiplication. How about 7 and 3? We can see the a colon and the b colon, which is again just telling us what these hard data values, what variable they belong to. And I could, print the results here, and we would not get 30, but we'd get 21. I used the wrong variable here. Diff results, not result. Like, I thought I did the math wrong for a second. Yeah, 21. And this becomes really useful because oftentimes the whole point of using a function in the first place is that there's really two possibilities. So we're on to our next little topic here. We kind of talked about how functions work. Now we're talking about the why. Why use functions? I'm going to write this one out though. Why use functions? There's like one or two, maybe three reasons. One, we can reuse code. I didn't have to redefine this code here, right? Because this code should work for any numbers, a and b. Anything should work. If you want to talk really mathy, a and b here is like the domain of our function, domain and range. All the possible inputs are a and b. And really anything is allowed so long as you can multiply them. So we're looking for any numbers here. And the possible return values are also any numbers. Okay, if you really want to get tricksy, technically this operator works with strings as well, but yeah, it could work if it was a number and a string. But anyways, we're not trying to be tricksy here. So reusing code. Another really important use is, I'm going to say organizing code. If you don't use functions, the thing that's going to also mess you up is that it's going to be harder to understand what all your lines of code are really doing. Simply having another label on what is being done here vastly improves the readability of your code. So let's look at an example. Let's go back to this large game here. There's about 1 million functions in here, so we should have lots of good examples. Let me find a good example though. Maybe we'll go, let's find play screen. Yeah. Okay, where are all these functions called? Is it called, oh, I know where they're called. let's forget that. Let's look at one of these functions. Let's look at this one. Handle events or update. No, let's do rent. No, I'm so indecisive. Exit screen. Let's do this one. Okay, what's happening here? Well, we know just from the function name that this is something we run when we're playing the game. This is what happens when we exit the screen. In fact, I have a little note here to tell me what exactly this function does, which is also really useful. And the note says, determines whether to play a new puzzle or to go to the end screen. See, this note is really helpful because if I was just guessing, I would have probably just said we exit the game. But this helps remind me that we can, from this function, either play a new puzzle or go to the end screen. There's options in this function. And I wrote this long enough ago, which was, let's see, I probably wrote this function 7 months ago, maybe 8 months ago. And just in that long, I forgot what it did. So these little comments, are really helpful. And we're going through a function. We got a cool if statement. I have little notes to say what it does because you could forget that too. But I'm going to skip over that. And then we reach a function. And just like that, the name of the function is really helpful. I can clearly tell that there's some kind of clock and we're removing it. Why we're doing that and the circumstances for when we do that, I would have to spend more time to figure out. But just having this function name here is just, instead of writing out that code, is really helpful. But let's look at remove clock and see. I'm going to say Control F. Control F stands for control find, and it is a really helpful way to navigate your code. And this works in many platforms. And we can see here, remove clock's pretty simple, right? It's just 3 lines of code. If we just wrote out all of our functions, my function that I was just looking at, which was end exit screen, it would be that much longer. And this is already a long function. If you could imagine this being, let's say, 50 more lines of code, that would be a lot to look at. It'd be hard to tell like what even belonged to these if statements. We can see here that these lines here are inside this if statement. And this line here is inside this if statement, and that this if statement is inside this if statement. So we can actually see this all on the same screen. But I guarantee you, if we were writing out all of the code in end puzzle and remove clock, this would not all fit on the screen. And it would be that much harder to understand what's happening in just this if statement. So a good programmer, here's a really important rule. A good programmer is always thinking about how to divide their code into more readable functions, because functions are ultimately going to be more readable and they're going to be more testable, and they will reduce code. They'll improve on code reuse. We won't have to write the same thing multiple times. And if I look up end puzzle, I would imagine this function is a longer function. Let's find it. Yeah, this function is many lines, maybe 10 or so lines if we don't include the comments here. So that would be a lot to put in our code here, right? Adding 10 lines, that's a lot. Okay, so that's our example. Hopefully that's a good enough argument. Are there other reasons for using functions? Yeah, there is. We're just going to keep this list at 2, but there's definitely more advanced reasons when we introduce more advanced concepts, probably beyond this class. I don't know if we'll need to add much more to this list, but definitely there are other reasons. So, and in part, I'm trying to make an argument here. I'm trying to convince you to use functions as much as possible. Yeah. Okay. What is the next section? We need to talk about the use of understanding the use of parameters and how they work. We kind of did that here, but let's do another example.